Welcome to the slop farm. Enjoy the video.
You begin by verifying prerequisites and taking the first actionable steps. Install Python 3.8 or later and create an isolated virtual environment. This prevents dependency conflicts. Make sure GPU drivers are present if you will accelerate training. Next, pip install NumPy, Pandas, and your chosen ML framework so you can prototype immediately. Then load a representative dataset sample, 1,000 to 10,000 rows, and inspect labels and missing values. Doing this now saves time later when you start model iteration. Once done with data checks, you move into feature engineering and model setup. Clean and impute missing values and encode categoricals. Use one hot for low cardinality, embeddings for high cardinality, to preserve signal. Scale numeric features and create interaction or aggregated features if they improve expressiveness. Then define an 80/20 train/validation split and select a baseline model, such as a regularized linear model, decision tree, or a compact neural net. Train quickly to establish a performance baseline and identify which features matter most. You now finalize by training, evaluating, and deploying. Train with early stopping and log metrics like accuracy, awk, and loss curves to spot overfitting. Once validation looks stable, test on a holdout set and calibrate decision thresholds where needed. Also profile inference latency and memory to meet production constraints. Deploy as a REST API or scheduled batch job, and wire up monitoring for performance and data drift so you catch regressions early. If predictions degrade, retrain using recent labeled data as the primary fix.
Thanks for watching. Consider subscribing if we helped you today.